I'd like to begin by thanking the sponsors that made this session possible for all of us to attend here. And that would be Dr. David Lightfoot and Dr. Rita Teutonico from the U.S. National Science Foundation, the Division of Social, Behavioral, and Economic Sciences. Through a funding to my university, they made our gathering possible for this session and workshop. I also want to thank Mike Murphy from UNESCO, who was very, very helpful in rendering all the logistics very smooth and everything working out well. We had to make some, as a small but complex adaptive system, of course, we made some adjustments and adaptations to our program. And the composition is more or less the same, but the order of the speakers is somewhat different, determined by the actual content of each presentation. The first speaker will be Nigel Gilbert from University of Surrey. He will be followed by Hiroshi Deguchi from Tokyo Institute of Technology. Third will be Klaus Treusch from University of Koblenz. And he will be followed by Jose Manuel Magallanes from Pontifical University of Lima. And I will go last. My name is Claudio Cioffi, and I will be following this session. So Nigel, if you would begin, please. Oh, let me just mention that each presenter has about 15 minutes, and we allocated that time in order to make sure that we have sufficient time at the end for some questions and discussion and follow on. So, welcome, and I hope you enjoy the session. Nigel?
Something happening? Okay, right, good. Well, good morning, everybody. It falls upon me to sort of introduce this, and so I promise you no equations, no complexity, only simple complex systems. What I want to try and do in my allotted 15 minutes is to suggest that complexity has something to offer to social science. And in the subsequent talks, there'll be more details about just what that is. But to start off with, I wanted to just sketch out what I see as the interesting or perhaps even critical issues that complex systems and the complexity approach can offer us. And I'm very glad that we have got this session today, because I guess, like you, I've been attending the kind of keynote sessions, the keynote lectures. And it seems to me that both Sen and Elster have unconsciously, I would say, prepared the way for what we're going to be talking about today. Because both of them raised issues which we have the answers for. Well, whether that's really true, we shall see. Okay, so I want to say things that will be kind of known to you, but I want to highlight, first of all, that social systems are actually complex in the sort of everyday sense, but also complex in a slightly more technical sense. And I'm going to say that they're non-linear, they're multi-level, they're emergent, they're open systems. But one of the things that you're going to be saying to me, I suspect, or have at the back of your mind is, well, complex systems, the complexity approach was really originated in mathematics and physics. Aren't we proposing to do just the same as many others have tried to do, which is to turn social sciences into natural sciences, to try and put forward the idea that you can analyze a social system as though it was a physical system. I want to start really right off at the start by saying that no, there are important differences, but ones that a complexity approach can handle. Okay, so what I want to end up with is suggesting that this complexity toolkit does have something to offer, and I'm going to suggest very quickly some fields in which it is already being useful. So let's actually kick off with some statements that that kind of highlight why complexity might be of interest. First of all, that social systems are non-linear. Actually, we mislead, I would say, our undergraduate students when we give them courses in social statistics and we teach them about ordinary least squares or regression or structural equation modeling or whatever. Because actually, if you look around social systems, you look around you in society, you do not find that many social phenomena which are normally distributed in the kind of way that those sorts of analysis methods assume. Actually, wherever you look, and I've put a few examples up there, you get power laws, you get non-linearity, you get situations where there are very few very big things and very, very many very little things. You get situations where there are interactions between things, between units, between people, and where those interactions matter. So social systems are much more non-linear than they are linear. They are also multi-level. And here we go back to Elster and his comments. But I would say that they are clearly, obviously, multi-level, but we don't want to privilege a particular level, as John Elster was trying to do it in his lecture. We don't want to privilege the individual level, a methodological individualism over any other. All of these levels are important, and what we need to do is to have tools and techniques which take that seriously, that allow us to examine things at all of those levels at the same time and with similar importance. Thirdly, we as social scientists are, of course, interested in emergent phenomena. What's going on here? Well, each of these cars, the driver has been told simply to follow the car ahead. And they go round in a circle. But as you may have practical experience yourself, what very quickly emerges is a traffic jam. Just watch. This is I think, a delightful example of emergence, but as social scientists we can imagine, we know of many more examples from groups to institutions, to organizations, to nations, and so on. And that finally, from my list is that social systems are open systems. That means that energy, for example, flows or resources flow through the boundaries of those systems. This is just a little map of the world, of course, in which the light shows the energy being used, nighttime lighting, but the superimposed on that, the red patches are the sources of those energy, and of that energy. It illustrates quite nicely the differences, geographical differences between the, if you like, the sources and the sinks of energy usage today. Okay, so multi-level, emergent, open systems with non-linearities. All of those characteristics are true not just of social systems, but of many biological systems, of many physical systems as well. So aren't I committing that fallacy of just analysing social systems as though they were collections of atoms or collections of ants? Well, no. I think it's important that we recognise also that social systems and people have other characteristics that are important and we need to bear in mind in our analyses. And these come from the fact that people understand what's going around them, or try and understand what's going around them. They socially construct categories. They analyze reflexively. This brings us to what has come to be known as either second-order emergence or emergence. And I think that it's worth spending a moment on what I mean by second-order emergence. This is, I suppose, a new name, perhaps an unnecessarily new name, for something which is buried, I would say, in many texts in social science, and will be a theme of the talks today. What is second-order emergence? It's the idea that with individual interactions, interactions between actors lead to the emergence of social structure, but that social structure has a downward influence on individual action. This is important because this is something that doesn't happen with physical and biological systems, this second-order emergence. Here's just a very quick picture. There's a very famous model called the Schelling model of residential segregation. It's a kind of abstract model of why we get, or abstract theory, if you like, of why we get ethnic segregation, even if the individuals are relatively unprejudiced. But we can also elaborate that model to show the effect of ethnically diverse neighborhoods influencing the preferences, the locational preferences of households and where they move. So we have, first of all, the emergence of ghettos or emergence of racially segregated neighborhoods, but the fact that particular neighborhoods are labeled as black, red, white, poor, rich, whatever, has an effect on where people move to. So I want to suggest then that, given that complexity science does provide a way of thinking about the link between the social structure and the individual actor, the micro-macro link, that is a new way of thinking about it, and that dissolves some of the puzzles that have bothered social scientists since at least the turn of the last but one century, and perhaps before that. And to demonstrate that, I think I'll leave some of the other speakers today to give you specific examples. It also, this particular approach is intrinsically dynamic. It's intrinsically concerned with process and time. And as such, it helps us to get away from the, I would say, the characteristic that of obviously not all, but of much social science, to focus on the here and now rather than the passage of history. And in that, I guess I'm echoing the complaints of John Elster, who said, "Go read some history." Excellent. And also this approach encourages taking account of space, of geography, of location, and also taking account of interaction and networks. It's very closely associated with social network analysis, for example. And finally, it encourages us to, again, like John Elster, but different from him, encourages us to think about mechanisms, but not necessarily the kind of mechanisms that he was talking about, which are kind of cognitive heuristics, but a whole range of mechanisms, including ones that are actually social mechanisms. Okay, so that's the prospectus, if you like, what then can we do with this? Well, I want to flip through in my last 2 minutes just a list of examples of where this kind of approach is currently being applied. You'll get some more specific examples later on in this session, but just to give you an idea, and it's a very wide range here. In economics, analyses of markets, of firms and networks of firms, and behavioral economics, game theory, experimental economics, analyses of that kind. In geography, a great deal of work modeling land use. I talked about segregation. That's a very straightforward, a simple example, if you like, of clusters, of epidemics, and of traffic. In politics and sociology, this is just a little model of what's called opinion dynamics, showing situations in which we can get the division of an electorate into two or more extreme parties. Opinion dynamics in analyses of trust and reputation, increasingly important. Think of eBay and so on. Of new social movements, of voting behavior. And then finally, just the take-home message I want you to take home from this, that complexity science approaches can provide a potentially useful toolkit for understanding social phenomena that deals with characteristics of societies which are fundamental to social science. Issues such as interaction, emergence, nonlinearity, and which are already beginning to provide models and ideas that can be applied to different kinds of policy. My clock says that I've exceeded my time by 24 seconds, so I think I'll be forgiven for that. Thank you very much indeed.
Speaker is Professor Hiroshi Deguchi from Tokyo Institute of Technology.
Wow, thanks. Hi. Today, I'd like to talk about agent-based social system science for understanding and designing complex global society. So, my agenda is 5. And social science have been divided into conventional research program, as you know well. And the second, social simulation as a tertiary, third-level modeling language, and social simulation language, and we also talk about our social simulation language platform. And the third one is agent-based social simulation can restore the gaps among different disciplines. And last one is social simulation and new humans sciences as a neoliberal arts. So at first we start from commensurability gaps. Now the commensurability gaps among social sciences are becoming more serious for drawing our intellectual map for the global society, as you know. Well, there are so many fragments of paradigm. So, social and semantic layer, and social and functional layer, and personal decision layer, and personal meaning and understanding layer. Maybe around here, understanding and interpretive layer, and rational and functional layer, and micro and personal layer, and social and macro layer. So we have to accommodate not by unity, but by commensurability. So these gaps are becoming more serious, and the rapid expansion of complexity of our knowledge for the world. So especially in the area of social science and humanities, we need the way of bounded rational, intersubjective, and participatory construction of knowledge for the world. So part 2, social simulation, is the tertiary language. This is a very important message. And of course, the first one, primary one, is the natural language. And the secondary one is the mathematical language. So language is used for describing ideal type or model to explain and understand the world issues. So natural language, first one, of course flexible and interpretive and easy to understand for everything, but ambiguous. And mathematical language, I love this one. Robust by theorem. Strong explanation power, but difficult for ordinary people. And they exist implementation problem. That means how to apply the model to the real situation. Okay? And the social simulation language might or will bridge the gap. So now look some example of agent-based social simulation toolbox. The one is the informed consent model for brain operation of aneurysm by simulated reality. So compare option of an immediate surgery operation with the delay of the operation. This is the delay case. And this is work collaborated with Dr. Nagata, doctor of brain surgery, who operated my brain. So this is my example. Very useful. And another one is also useful one. Smallpox bioterrorism simulation. Well, that means, well, we talk about it later, but well, now, the start that one scenario simulation now. During the presentation, maybe smallpox infection will spread on this virtual city. Consists of 10,000 people living, agents living in this simulated world and social structures. Okay, so the example is the depopulation process of a small village, my student's village. There are so many scenarios, possible scenarios. We can compare these scenarios concretely and discuss and discuss and discuss as a communication tools. So that's the point. So what kind of ideal type is given by social simulation language? Social simulation language creates a social simulation model as a cluster of concepts such as epidemic infection model that gives the dynamical ideal type and support to understand the dynamical change of a social phenomena by showing possible scenarios explicitly. But of course, social simulation might create a simulacrum instead of a proper ideal type, of course, as you know, like a natural language. So, social simulation should be designed not for formal scientific verification, but for combining fragments of knowledge. So social simulation supports better communication and the construction of common understanding among stakeholders of the problems. So simulation on computer, simulation on silicon should become better than simulation on brain, or biased or prejudged belief by stakeholders. That's also the point, I think. And now we'd like to talk about our simulation platform called SOAS, Spot-Oriented Agent Role Simulator. It's a new type agent-based simulation language which requires a little skill of programming. SWAS is designed for domain experts who have their own problem to be solved. What they have to do is to use SWAS several hours for getting basic skills for modeling. SWAS also support making a web-based gaming simulation. So please try SWAS. You can download from here. Please memorize this URL. Now SWAS 2.1 can be downloaded, and also you can download all source file, open source. And part 3, agent-based social simulation can restore the gap among different disciplines. So social simulation supports interdisciplinary research at first. And second, social simulation gives shared internal model to our society. And third, real-world grounding of social simulation by social statistics. Okay, so anti-pandemic agent-based social simulation model supports interdisciplinary research. That means, well, that requires pathological transition models from medical domain, okay? So level 1, 2, 3, and death rate, and recovering rate, and so on. And also it requires city structure models, so city engineering domain. And also human activity models, or demographic structure of family, and then so on. And also infection process models. So too complex, it is not a medical domain research, but a real interdisciplinary research. But well, social simulation can combine the fragment of knowledge. And this is an example of anti-bioterrorism simulation tabletop exercise with different stakeholders. It was done by Global Security Center at Keio University. It's me. And in this tabletop exercise, simulation-supported tabletop exercise, well, not for Oracle, but for clarifying and evaluating possible options of scenarios. Actually, for this exercise, we have constructed 216 scenarios. And this is a professional, National Defense Agency and vaccine production company and so on. Unfortunately, this is for smallpox terrorism, not for swine flu. But anyway, we're now constructing. And the third and important issue is the real-world grounding of social simulation by social statistics. That means, as you know, there is a primary statistical survey. Of course, it's very important. And the secondary, processed statistics. That means like a SNA, System of National Accounts, or SSDS, Systems of Social and Demographic Statistics. But we say the importance of third layer, estimation of social options of possible scenario as a higher order statistics, supported by, well, agent-based social simulation. So message is simple. Tertiary statistics equal social simulation equal tertiary language. Okay. Now, we have just started Oshima Island total simulation modeling project for anti-pandemic and evacuation against eruption and demographic and socio-economic situation in cooperation with Oshima Town and Oshima Medical Center. Oshima is near Tokyo. A small island. 8,500 people are simulated on our Oshima agent-based social simulation platform. Okay, last part. Social simulation from where to where. So the term liberal arts, as you know, consists of arts of language for describing, navigating, and estimating our world, such as arithmetic, logic, rhetoric, grammar, geometry, and astronomy. In Oriental world, Motz, we say Bokshi, Motz and his school has created a similar concepts of liberal arts, including logic, rhetoric, optics, ethics, and the oldest concept of social simulation. Actually, tabletop exercise for peacekeeping. So we have to innovate agent-based social simulation as a tertiary language that supports new liberal arts for recognizing, understanding, and redesigning the micro and macro, functional and semantic system of our complex global society and the related life world in this century. And from economical, political, sociological, organizational, and cultural point of view. Thank you for your attention. Go back to our simulation. Now 50 days have, almost 50 days have left. And the red line means the infection. And this means our body, reproduction. So one patient, average 4.5 person infected by one patient. That means, well, and then so on. So thank you for your attention.
Our next speaker is Professor Klaus Treusch from University of Koblenz.
Well, good morning, everybody. I want to continue this series of talks on complex systems with some more details about the differences between different kinds of complex systems and different kinds of complexity. As Nigel has already mentioned, we have differences between physical systems, living systems, and human social systems. Physical systems consist of particles which just obey natural laws, while living things are at least partially autonomous. At least mammals and primates and so on seem to be able to make something like decisions, having alternatives, while human beings as parts of human social systems are entirely autonomous. They can decide not only about their actual behavior, but also about the rules they want to follow. We are above a level of just being guided by instincts. Physical particles interact only in very few different modes, by gravitational forces, by electromagnetic forces, and so on, as physicists are talking about. The elements of living systems interact in several different modes. They can touch each other, they can make sounds in order to advertise some danger, but their symbol system is if there is one, relatively restricted, while human beings can interact in numerous different modes, as we just currently are doing, interacting by talking and listening, by showing each other slides, pictures, and so on. Particles have no roles in the same way that human beings have roles. Living things have roles. They can give birth to another living thing. They can mate, so do this in different roles. We humans can even take on different roles at the same time, as I will show in one of the next pictures. And we are aware of our roles, and we can actively play our roles. Physical systems are by no means conscious of their interactions. In the case of living things, of animals, we are not sure about their consciousness about what they are doing, but when we are talking about human beings, we know that we are conscious of all of our interactions and of our roles. Particles, physical particles, do not communicate in any reasonable sense of this word. Living things do. they can exchange sounds, but they would never communicate about contrafactuals. But we can do. We can talk about theories, we can talk about unicorns, we can talk about angels, things that do not exist. The interaction between physical particles is by very few different forces. Living things interact with chemical substances, concentration gradients. Physical particles move within fields, which they change with the help of their moving. Living things also use sounds, as already mentioned, but human actors interact by sounds, graphical symbols. We have an unrestricted lexicon. We can refer to absent or non-existing things. We observe each other. We predict next moves, which other animals can perhaps also do, but we are in a position to being able to derive regularities from what we observe. This is what social science is about, but even without social science, we are able to derive regularities from what we are usually observing. Moreover, the complexity of systems of all kinds is that systems can contain systems, so they are systems of systems. And this is particularly true for systems which consist of human beings. As I will show with a very everyday illustrative example, the different roles that we can have at the same time make it difficult to attribute different systems to different levels. So we were speaking about levels, but it is not very a simple concept. Think of a person, call it A, who is married to another person, B. These two form one of the most primitive human social systems, a married couple. This married couple has children, 2 children, so there's another relationship. This is the relationship of being married. This is the relationship of being a child of another person. These children will marry sometime, forming another system of the married couple type, and the same applies to this one. And all of them form another system which we can call a family. So now, do we have 3 levels now? Individuals, married couples, and family? I don't think that this is the right order. And this becomes more complicated when we think that person B owns a firm. Obviously another type of system. And he is the boss of a person called G, the director. And this one is responsible for 2 divisions within this firm. So another kind of 3 levels, employees, divisions, the firm as a whole. And now we see that the son-in-law, C, is one of the members of this division. So we have different paths of interactions between the father-in-law and the son-in-law, once within the family, once within the firm. And we can continue this, and in the end, we might find that within this firm, 2 people marry. A system, a very simple kind of description of systems and the relations in there. And when we look at this complicated system of systems from outside, then another concept of level shows up. Here we have the level on which we can describe the individual relations. Is child of, is married to, is superior of, and so on. And this person is a part of this couple, and this division is a subsystem of the firm as a whole. And on the top level of this conceptual level system, we can think of the household or the family as part of the national economy. The same applies to the firm, which is also part of the economy. And there's also a relation on the top level between these systems, namely households provide labor force for the economy. I continue to speak about levels, but I'm a little bit reluctant. The concept of level is perhaps not sufficient to describe the complexity of our social life. But anyway, we are accustomed to use the words micro and macro level. Most of you will know Coleman's boat, where he describes the relations between the macro and the micro level, restricting himself to just these two levels, and describing something like downward causation and upward causation. And let us have a look at how this works in different kinds of systems. In physical systems, we can, the interpretation of this, we can adopt this interpretation in the following. The macro cause in a physical system is a field which exerts a force, something like a downward causation, which makes a particle move, and the moving particle changes the field, so we have something like an upward causation. In social systems, we sometimes also speak about social fields, but I would rather speak about social norms, which emerge into the individual. The micro effect is that the individual adopts a norm, and the upward causation would be a norm innovation. I will give an example a little bit later. Let me first continue here to make clear what the difference is. I come to Durkheim a little bit later. The effect of downward causation in physical systems is more or less transitory. So the particle falls back into its former state of a lower energy level or whatever it might be. And usually even the upward causation is also transitory, as there is no memory on either level. Particles and physical systems have no memory, or at least a very restricted form of memory. While in the case of social systems, we have a downward causation which usually lasts for a long time. Downward causation is, for example, learning in school. What we learn in school lasts for a very long time. It changes the state of the microentity forever. Falling in love, for example, changes the state of the microentity forever. So we have a very extreme path dependence of the behavior of humans and of human systems, which makes a very big difference between physical and social systems. The effect of downward causation is stored in a long-term memory, not only in the individual, but also in society. We have folklore, we have libraries, we have codes of law. And this is why we sometimes observe what Pierre Sarret, the day before yesterday, mentioned, that the force of law is superior to the law of force. The law of force also works within physical and living systems, but the force of law, I think, works only among ourselves. How do we interact? We often use the pheromone metaphor, thank you, where chemical substances, for example, describe the behavior of ants. They follow the concentration of some pheromone that their colleagues sent around. In simulation, we often use the telepathy metaphor, where agents read directly the memories of other agents. A technique which is very, very simple, but of course more or less unrealistic. But we should use the message metaphor, knowing that messages do not necessarily express the objective internal state of the sender agent, because we can counterfeit the objective state. Well, this message metaphor has to be used as in simulations of economics and social processes. Software agents should be able to exchange messages that hide or counterfeit their internal states, which would not be possible with the telepathy metaphor. This makes it necessary for software agents to have something like a language or symbol system for communicating. We, as living humans, have the advantage of having more or less been born with such a language. Our software agents have to learn something like this. And these symbol systems in our simulated agents will have to refer to the components of agents' environments and to the action they can perform, because software agents do not have bodies with which they can execute all this. Let me give an example for a norm invocation message. This could be something like A says to B, I don't like your smoking here. And this would motivate the individual agents to change the rules controlling their actions. So B abstains from smoking in the presence of A, not only this time, but only next time when he meets her. And if this happens open enough, now I come back to Durkheim, to Emil Durkheim, who coined this, then a sociological phenomenon will penetrate into us by force, or at the very least by bearing down more or less heavily upon us. This is how a famous French sociologist coined this nearly 120 years ago. And as a consequence, these norm invocations and the resulting behavior occur more and more often and become a sociological phenomenon. Not only B, but others too abstain from smoking, not only in the presence of A, but also on other occasions. And this is what we should be able to model. We programmed something like this in an agent-based simulation system. Here, on this part of the picture, you can see a couple of children moving around between two meadows on either side of a street where cars move from north to south. They start from somewhere here and they want to go to this attractive red cross. And what they learn over time, you must not cross the street when I'm approaching in my car, B. And then B, one of the blue spots over there symbolizing children, abstains from crossing the street when A is approaching with her car. And after some time, not only B, but others too abstain from crossing streets, not only in the presence of A's car, but in most other cases. They look first left and then right to find out whether there are any cars arriving. So we made it work in this very simple example, and you may say this is a toy example, so let us see whether we can use this technique for policy modeling, as Hiroshi has already given some examples of. We are currently working with some less simple scenarios. One is about the emergence of loyalties within criminal organizations and of the collusion between criminals and victims in the case of mafia extortion records. A problem which we will be tackling in one of our next projects. Another is the emergence of practices in microfinance. Under which condition will a small group of poor people receive a loan from a bank, and how will they organize paying back the loan, and so on. We might be interested in the ways and practices of spontaneous formation of teams according to the skills of individual members by exchanging messages. I can do this, so can I help you, and so on. Messages like these, and simulations of this kind work quite well and give us some insight on how an organization like a call center, for example, could be not organized but self-organized. My last example, the emergence of trust in online transactions between sellers, intermediaries, and buyers. Something which is very often supported by software agents who do part of the traffic, and which software agent must learn how trust can be defined, how trust can be proven, and so on. Last slide. What will computational social science contribute to a better understanding of complex social systems? First of all, it will teach us to be modest in our promises. The complexity of our current formal simulation models is still humble as compared with the complexity of real-world social systems. But if we compare this to earlier approaches of modeling complex systems, the equation-based and the particle or swarm-based modeling, agent-based modeling as a tool for computational social science has a better chance to progress beyond the limits of our current scientific understanding. Thank you for your attention, and I hope I kept my time.
Our next speaker is Professor José Manuel Magallanes from Pontifical University in Lima.
Okay, good morning. Thank you for coming. Well, my presentation is kind of different. I am not going to teach you about complex systems or agent-based models. In fact, I'm going to make many questions, and questions I don't have an answer yet. So that's what I call my presentation. It's about concerns about public policy, education, and new technologies in developing countries. Of course, thinking about the way we always treat them and the way we research about it. And like just to start, I asked myself, why do we need public policies, all right? So, well, the answer is kind of easy, because we want to get some direction for the future. We want to change what we are doing, we want to improve what we are doing, and we're gonna go to a future that we think is better, so we plan it, okay? So there's always this part, direction, to go into the future. And I'm going to focus on some of these dimensions: knowledge, regulation, intervention, and enforcement. Why? Because the present we find problems, but as a matter of fact, these problems are not for everybody. Some of us dislike what's going on, but some of us benefit from what's going on, right? So that's the difficult part of it. And when somebody says, okay, this is the policy for education, this is the policy for health, or whatever else, these solutions, okay, is the same thing. Some people will like what we propose, and some others don't. So this is how we start to begin all this complex thing. Another thing about the power that people in general have nowadays. Maybe before, all right, before it was easier when we have tyrannies and empires, but now we have democracy, all right? So now people in general have more power. That's very nice, but however, it brings more governance problems. Besides that, secularization, okay? If before our systems, our policy was always embedded or included religion, included some faith in all these systems, it was easier to convince people or to threaten them. Now it is not that easy, all right? So the easiness for the enforcement of any public policy we may devise, when we think of, is decreasing in a way, because now everybody talks, everybody has an opinion, and everybody has voice. So it makes this scenario kind of very, very complex. So we can always ask about the effectiveness of public policy, all right? So now you have in the future, I think, this leader, all right, with so many people asking for so many things, all right? And it was in all times that this person was the head of a hierarchy, but now he finds himself in a network. So it is difficult when there is no a monocentric power, but a polycentric power. So as Professor Nigel said in the first talk, what are we doing when we teach people about public policy, all right? When people do research about it. In general, we have some assumptions. No? The assumptions that, we have some ability to predict the future, all right? If we do something like this, if we collect X million in foreign investment, that's what we say in developing countries, all right? And poverty will reduce in some years, all right? So we are all expecting your money, all right? So that we can stop poverty in our countries, all right? But that promise is about 20 years or so. Every new president that comes, he says that he's going to foster investments, and the people feel that poverty is the same or even worse. All right. So what's going on? What are we doing with our leaders, or what are we teaching at the universities? All right. Maybe is everything failing because of that? It is a curious thing that this forum has the title of One Planet and Worlds Apart. And it is also very interesting that there is a political science world event in July that says the name is Global Discontent. All right? So what's going on? What are we teaching the policies and the people who's ruling are not, let's say, they are not ignorant, all right? They study somewhere, they got master's degree, PhD levels, all right? So what's going on? So the problem we think is that maybe what we are doing at the university is not enough, or is failing too much. So the scenario changes dramatically if we don't think that there is a linear way of thinking, okay? If we suddenly change our paradigm, and then we start considering, maybe, that all the professors here giving you lectures and telling you about complexity, maybe they are right, okay? So nobody knows the truth, really, but there are some people, like some of us, that's telling, not today, not last week, but for some years, some decades, all right, about complexity, about social complexity, all right? But are we paying attention to what these people are saying, really? So if we believe that, we have a problem, because our education is not ready for that. The people who are making policies may not be ready for that. There are new challenges in the future. Let's think about the future. Forget about the present, all right? Let's think for a minute about the future, all right? So I have in my classroom, I teach political science and government, many students that I know someday they will be the leaders of my country, they will be the policy makers, right? And so what challenges are going to face? Well, at first they will have to solve the problems that we couldn't solve, right? And the new problems that were coming, all right? So we don't know how many problems they are going to face, because what problems are we going to solve at this moment, right? What problems are we going to leave unsolved? For example, everywhere where we say that we need democracy, all right? And there are authors like Bobbio that says, well, okay, democracy is very good, all right? But we still have some promises unfulfilled. Okay? How many promises unfulfilled will there be in the future, right? For example, that groups are preferred over individuals, like Bobbio says, the defense of private interests over the nations, the permanent presence of oligarchies, and so on, all right? So being a Democrat in a society that's too complex, where everybody wants to talk and everybody believes they have power, is kind of difficult, right? So just to say something, imagine that we want to simulate something like this. Let's simulate a democracy, all right? So I am not telling you what social systems or the current example we have, but let's see the problem in the other way. What are our problems, and let's see if what could we do only with statistics? It caught my attention last month. There was a presentation in a national office in my country, all right? And there was authorities, and they presented national statistics for the last year, right? And they say we have invested this amount of money. There were 200 people in all the country asking these questions, all right. So at the end, they showed us the statistics, and the conclusion was, we need a better democracy. So I say, why do we invest so much money? Because at the end, somebody says everything that we know. We need better quality of democracy. We knew that. You need to invest so much money to tell me that, all right? So I don't know what's going on. So I don't want to say that we have kind of stupid leaders in our countries, right? But I say that at least they don't know what they are doing. So let's simulate. I say let's simulate about this. And so one day, I decided, okay, I want to build my world. Okay, I want to build my world. I want to have an authority there. I have two public policies, and these people around here. Right? I just wanted to do this because I said, all right, what happens if the person up there is kind of a Democrat person? He pays attention to what everybody says, all right? But since he cannot talk to everybody, he just do some polling. He polls 10% of people, okay? and according to what he finds, he just changes what he's doing, right? So I just started working like that, and I say, okay, I have a Democrat. Here I say, this is in Spanish because I used to sell the idea in my country. This is a Democrat, all right? So I say, okay, let's see what's going on when I allow the citizens to interact, okay? And allow the citizens can interact, they can change ideas, they can think about what's going on, they can have a position, all right, about what the mayor is doing or the authority is doing. But I have a problem with this simulation, all right? Maybe something's wrong, but the problem is that every message that you see there, that is in Spanish, it says that a new authority has been elected. Okay? What's going on? So, because I elected somebody democratically, and this person has always a democratic profile. So he's paying attention to everybody, and everybody also can change the opinion. But when the more democratic I have this authority, nobody reelects this person. All right? And then I say, okay, let's change. They say, hey, there's something wrong with this simulation, all right? Because I changed to non-democrat, okay? And let's see if it happens the same. All right, he starts getting reelected, okay? So sometimes they don't reelect him, but something caught my attention because people like dictators, something like that, all right? But in general, we have many questions like this, but this is just an example, okay, of what can happen if we just pay attention to engine-based modeling, okay? Of course, there will be many critics about this, but it's just a start. It can be worse if we just use, I don't know, somebody said yesterday, I think, that if you're not convinced by the median or the average, that you can pay attention to that. But I am not convinced of that too either. So, and there are some more problems people are going to face. The scarcity of fossil fuels, okay? Fuel always brings the problem about new wars, about political negotiations, what's going to be this future. There's also another concern about the convergent technologies, all right? So now everybody's talking about the new technologies. 2 weeks ago, I believe in Europe, there was a conference to talk about new technologies. But in our countries, in developing countries, we just listen to that like news. Okay? We are not discussing that. We don't know what part of the story, what will be our role in this story. Well, what about simulating all of these problems, all of these concerns about new technologies in society, about weaker ecological systems in the future, about everything connected? So the problems with democracy, the problems with technology, the problems with the fuel, the ecological problems, everything together. Okay. So I didn't do that, right? But it will be a nice program to start. And another thing that I wanted to ask is if it is naive to think that there will be a better future for everybody. Okay? Is it very naive to think about that? Well, at least I wanted to know, if our current paradigms, as I mentioned before, will lead us somewhere. Okay? If using the knowledge we have and using the technique we have is going to take us somewhere, a better place at least. As you have seen from our speakers today, developed countries are making some advances. Right? In the United States, in Europe, in Asia, there are people who are studying these things seriously, are working also to promote what they are doing. But my concern is in my area, in my region, in Latin America. Okay, what we are doing, right? And I had to take a look to what we are doing, and I before coming, I checked the programs in social sciences, and I found that in every university we have in Latin America, no formal course was found. All right, and not only that, all right. I also pay attention to our top 25 think tanks, and I find that this framework, all right, is not part of any research. Well, as some of us have said, agent-based modeling may not give us the answer today, all right? But I believe and I hope that you can see that it is showing us a new direction. The computational social science approach, as we also said, may be a way to unify what we believe is partitioned today. Well, we know what it's not working, so what are we waiting to go into agent-based modeling can be a good question. Speaking of the policymakers, speaking of our education systems in higher education. That's all. Thank you very much.
Again, magnifique. And so we come now to the last presentation. It's been very challenging for me, by the way, to keep the time on these speakers because of the interest, the high interest in the topics that they have been developing. But I thank everyone for really keeping good track of the time. My name is Claudio Cioffi, and the presentation I have for you today will serve two purposes. I wish to introduce what I think are a couple of new ideas, perhaps to add to the corpus, the emerging corpus of complexity science in social science. But also, perhaps you'll see as a way to provide maybe some sort of synthesis or summary of several of the ideas that have been proposed before. So I have those two purposes in mind. The reason why I chose to call this a manifesto of sorts is because I think it's high time that in social science, and by the way, I'm using that in the singular, social science, because I do believe, unlike perhaps some of the views expressed by the keynote speakers, I really do believe that there is such a thing as a core of social scientific knowledge that is cumulative, testable, reproducible, and starting to be transgenerational as well, which is good news. This is not right everywhere, but it is true to a very large extent. But I call this a manifesto because this is something that I would love to nail to the door of every social science department in various countries, including in my own country. Most of what I would like to say consists of a set of concepts described in a single term. But before I do that, I want to mention a few things by way of background. And the first thing I think that needs to be thought about, at least, is why do we have social complexity? Why is it that societies 10,000 years ago were a lot simpler than societies 5,000 years ago and 2,000 years ago and so forth until today? We have hugely complex societies today that are not only complex in the sense that the social relations are complex, but they're made even more complex by the fact that we come to rely on many technical systems, information systems notably, in recent decades. And when you take the whole connubium of human and technical organizations in interaction, we begin to appreciate what are some of the features of that complexity. I believe that the reason why there is social complexity is because humans individually aspire to a quality of life that they're incapable of providing individually, but they must act collectively. In other words, they have to organize in order to bootstrap to a higher quality of life. So, for example, the pleasantness of this great hall and the wonderful time we had last evening was sustained by a tremendous amount of complexity in terms of highly complex supply chains and processes that made that realization possible, right, in that sense. So to me, at least, the reason why social complexity exists, because why is it that we have social complexity, is because we aspire to ever-increasing standard of quality of life. And to produce that quality of life requires a great deal of organizational complexity. Computational social science is also beginning to have its own identity as a field. And the identity of the field is manifested not only through the application and development of complexity theory, but also through other parts of it, such as social network analysis, automated information extraction, and other fields that are comprised within this, but primarily through, I would say, the signal methodology of agent-based modeling as a flagship tool. Instrumentation is very important because computational social science is a field that is enabled by the computer. In other words, it's impossible to do computational social science and to investigate questions that are typically raised in computational social science without the medium of this specific type of instrumentation. And I mean that in the same sense as microbiology was rendered possible by Louis Pasteur through the invention of the microscope, which opened new frontiers for the study of life that were simply invisible before, and we had absolutely no clue that they even existed. The same thing is true through the microscope, through the telescope initially, radio telescope and other instrumentation which is used today. Nanotechnology has also been rendered possible through instrumentation. There are vast fields of scientific investigation which, like computational social science, are enabled or rendered through the medium of the instrument, and such as is the case with computers. So I mean the use of computing here beyond SPSS and statistical analyses of an earlier generation. It's also a field that has its own pioneers. Some of these pioneers, perhaps I would say, were not even aware that they were pioneers. Think, for example, of John von Neumann. Von Neumann never imagined that in the year 2009, Professor Deguchi would be running an agent-based model of a pandemic dynamics that traces its roots way, way, way back in von Neumann's theory of automata. And the same is true for many, many other examples. Herbert Simon is perhaps the most distinctive acknowledged pioneer of this discipline. And Herbert Simon, interestingly enough, very well known in political science and in other areas of social science, is just as equally known in many areas of computer science and artificial intelligence, something which many social science colleagues do not realize. Just as many computer science colleagues, by the way, are completely unaware of the contributions that Simon made to public administration and other areas of social science. It's a very interesting phenomenon. Computational social science is, by definition, interdisciplinary. And it is interdisciplinary because the kinds of problems that we take on through complexity and other principles are typically ignore disciplinary divisions that are of an organizational nature coming from the university world, which has parsed the study of society by departments. And finally, in the 21st century, computational social science should not be viewed as some kind of exotic, boutique kind of field, but actually an absolutely necessary and indispensable field of knowledge for the production and maintenance of quality of life in this century. So it's a very necessary discipline. There are lots of important topics in computational social science, and in the few minutes that I have left available, I cannot show you material that normally would take a couple of semesters for very obvious reasons. So let me just highlight a couple of these things. One, which is very important, is the question of origins. When did social complexity begin? And this is an empirical question to which we're beginning to have a fairly focused understanding in terms of its origins in only four places in the world originally. The first and oldest of which was in West Asia, or Mesopotamia. The second locus is in East Asia, in the Yellow River Basin and nearby areas. The third one was in the Andean region of modern-day Peru, particularly in their coastal areas. And finally, in Mesoamerica, in the Valley of Oaxaca and nearby and its vicinities. Everywhere else in the world, social complexity occurred either as a second-generation phenomenon, or in some cases did not occur at all, or very slowly until extraneous, exogenous actors arrived on the scene. Well, today, this very, very important puzzle of global social science, this is an area in which computational modeling is beginning to make some very promising progress. Another important question, especially for those of you who are in the political science tradition, is the question of governance. How exactly a polity operates in the same sense as an economy operates and so forth is something that traditional modeling never rendered possible. And something quite interesting is that some of the ideas behind the systems theories of Easton and Dahl and others of that generation, why they never produced a formal system that could then be testable and analyzed and so forth, was because those theories were rendered in terms of objects. They were not rendered primarily in terms of equations and variables. So the formalization of those theories was always very problematic. This is now rendered feasible through the object orientation of computational social science. And we are beginning to see for the first time the instantiation into agent-based models of systems models of how a polity actually operates in a way that, surprise, is actually understandable to policymakers. I mean, the basic structure of a polity is that it consists of a society and a system of government, and the government operates to manage public issues that arise in the normal life of every society, that these issues put pressure and stresses on society, and that stress, which can come in the form of either issues such as inflation, for example, or a national security issue, or any variety. These issues are managed through policies that are intended to mitigate or solve these problems, and the policies are produced through resources obtained from society, and those resources come from the economy of the society and so forth. So all of this basic metabolism and structure of society is now being rendered in computational form through models that are not only understandable to the social scientists, but also to the policymakers. That's good news. Structure is another defining feature of social complexity. And today we're beginning to have a better understanding on how the complex architecture of social complexity is organized. And it is probably safe to say that the serial structure behind many supply chains and basic mechanisms of governance, for example, just as the one I had up before, is probably in some sense serialized, because there are sequences of things that need to occur in some conjunctive fashion in order to produce policy, to produce collective action, to produce agreements, and so on. However, these systems would not be very lasting or reliable in any way, because all serialized structures are extremely vulnerable to individual failures of any essential component. And so polities, for example, would not really exist or form, and social complexity would be impossible if it were based only on this basic fundamental backbone that is serialized. So it must be the case, this is a theoretical prediction, it must be the case that in the real world there's a huge amount of parallelization through various forms of redundancies. Because were it not for that, social systems would not endure any length of time. And so having a fundamentally serialized structure that is within itself, as Klaus Deutsch was mentioning earlier, a system of system, In this sense, the parallelization is built around a backbone that is serialized. There are also important principles of social complexity that allow us to formalize and understand these. Nobody had equations before, so I had to put this one up to at least give some idea that at some point we do actually do some of this, some of this work. But the point of this is simply to say that the fundamental principles of social complexity as far as the architecture and organization of that complexity are quite well understood. And it is through that specification that we're able to design and conduct the simulations. Let me mention one point that was made earlier at the very beginning of the presentation. A very important feature of social complexity has to do with the property of scaling. And this notion that there are lots of little things, there are a few sort of medium-sized things, and the huge things are very rare, but highly consequential, and we need to pay attention to those. That scaling phenomenon, of course, is described by power laws. And power laws, by the way, were not imported from physics. They were first discovered in social science by Pareto and his companions 100 years ago. What that generation of early complexity social scientists failed to understand, however, were the deeper implications of power laws, which were more recently taught to us by colleagues in physics. That's the original contribution. For example, the fact that the exponent of the Pareto distribution actually has some critical values that Pareto and others were completely unaware of. And it's the linkage between the empirical power law itself and the theory of complexity, which is of more recent origin and still being developed. Let me summarize, because I'm out of time, and I shouldn't abuse that as the chair, and set a good example. I have a paper on this, by the way, that develops many more ideas, and I'd be happy to send a PDF of that to anyone interested. I'd like to leave you with 3 points. The first is that the social science of the 21st century will be computational. And it will be computational because of the way we're teaching students and the inevitable fact that 10, 20, 30, 50 years from now, social scientists will have to be conversant in complex systems, in their analysis and modeling and simulation, if we are to remain viable for policy. The second point is that the recent development of object-oriented languages in computing provide a lingua franca of sorts, more or less with the power that the calculus provided in physics for the formalization of mechanics, celestial mechanics in particular. Okay? The reason I say that is because the way we think about society as social scientists is primarily in terms of people, relations, associations, the way they're organized, institutions, beliefs, and so forth. We do not think about society primarily in terms of variables and equations. We have to force our way to extract relevant variables and equations to formalize our theories and so forth. Well, the object orientation in computing does precisely that, because variables and states of objects and their dynamics are encapsulated within entities, within the computational entities. And so languages like C++ and Java are to be promoted among our undergraduates. We actually have many undergraduates that know how to write some Java code, but they've not discovered that this is actually a very useful methodology in social science. We need to encourage that. And finally, my last point is that computers are the most powerful instruments that we have, in the sense that they open up new frontiers of investigation in social science in the same way that the microscope, the telescope, and so on open new frontiers of science, in other disciplines. So it's not simply for the purpose of number crunching, but for the actual investigation of parts of the social universe that are otherwise not accessible through other means. Thank you very much, and we have now time for some questions and answers and discussion, being about 10:30. And so I would like to invite, perhaps now this is finally a good time. Maybe we could sit at the table and take some answers, or take some questions, I would say. Yes, please come to the microphone, and if you don't mind, and would you say your name and where you're from, please?
Yes, my name is Sally Wyatt from the Virtual Knowledge Studio in Amsterdam and Maastricht University in Maastricht. First of all, I'd just like to thank you all for a very kind of educational morning. I have to confess, I've always rather been suspicious of such social simulations as being rather reductionist. And I've always had the deep prejudice that the kind of interpretative social sciences and humanities were much better able to deal with complexity. But listening to you all, I'm more or less convinced that you do know the difference. I don't want to sound patronizing here, but that you do know the difference between social, physical, and biological systems. This is deeply reassuring. But I now have a new worry, which is actually that these social simulations are far too social. But perhaps I've missed something, and I think this is perhaps particularly a question for Klaus and Nigel, and I was kind of reassured in the last speaker who did allude to kind of complex technical systems. But if I take Klaus's examples of smoking, it's not only about preferences and learning about each other's preferences. It's about whether or not there are ashtrays in the room, or sprinkler systems, or no smoking signs that threaten fines if you light up. Or speed bumps. I mean, in the field I come from of science and technology studies, this is a well-known example that Nigel might know about at least. You know, there are traffic lights, there are speed bumps. It's not just teaching children or children kind of seeing their little friends run over that makes them learn about cars and the dangers of them. And also biological things, viruses and things also have, I don't want to go so far as saying they have agency, but they certainly have effects on these sorts of systems. So, but particularly with the technological artifacts, I'm curious as to how you incorporate those sorts of entities in your models. So how can artifacts, how can actions at a distance be incorporated in the sorts of models that you've been talking about? Thank you.
Who would like to take that?
Well, thanks for the question and for the two examples you gave with the ashtray and the no smoking sign and the traffic light. At least the no smoking sign and the traffic light are also social agents because they are artifacts produced by someone else who wanted to prevent people from smoking or to prevent from crossing the street. And so in the example that I showed, just one small picture, we also have traffic lights as agents. And these traffic lights are, well, organized by some program as the traffic lights in the real world. And perhaps we can include a police officer in our agent-based simulation who changes the schedule according to which the lights change. Same applies to the presence of ashtrays. So agents, social agents and also simulated agents will always have to move around and to behave in some physical environment, and all the other agents also belong to this environment. I hope this answers your question.
I'm not sure I have a lot more to add. I suppose, these kinds of simulations as Klaus says, have agents and of different kinds, and if we want to, we can give these agents what capacities we wish, and so, as it were, taking actor network theory seriously is actually almost trivially easy in these agent-based simulations. You're asking us, if you like, how do we do the simple things? It's the complicated things that we worry about.
Well, I mean, they were simple examples, but of course there are much more complex technical systems in the world. So
Yeah.
it's how you model the interaction
Right.
between...
I think the answer can only be in the same kind of way. Yeah.
There are some examples of this. For instance, in in a project that we have at George Mason that is now in its third year, this is in collaboration with the Smithsonian Institution. We've had funding from the National Science Foundation to develop a set of agent-based models on the rise and fall of polities in Central Asia, Inner Asia. That's interesting because it includes, for example, the Mongol Empire, which from a complexity point of view is very interesting because it wasn't very complex in terms of decision-making organization, but it was the territorially most extensive polity ever created in the world. And so this is a very puzzling thing. How do you do this with such a simple type of organization? And it was a challenge to replicate those dynamics. But in that case, we had to collaborate also with natural scientists, with ecologists, with climatologists, and so forth, because the time span was sufficiently long that there was actually climate change on that space. So the northern forest sort of moves up and down a little bit, and because it moves, the Gobi Desert actually moves spatially, and when those climates change, the animals undergo different patterns, and because many of these are nomadic societies and the people follow the herds follow the biomass on the ground, the biomass moves with climate, where you can see this whole thing. By the way, this is something that is way beyond the reach of game theory or any prior. I say this as a mathematical modeler who for decades worked on this. But agent-based models provide solutions to these kinds of research challenges that are starting to be somewhat insightful. There was a gentleman back there with his hand up just before, please.
Klaus Ellerbeck from the University of Frankfurt. I'm a sociologist, and all this has been very interesting to me because I have perceived modeling mostly in economics and in epidemiology. What I observed, as you probably did as well, was that, or read in the paper, that 200 people in Hong Kong spent an extra week in the hotel because there was one guest from Mexico among them. Well, this was just done by order of the authorities, informed by their experience from SARS. I think.
It was not Professor Deguchi's idea, by the way.
Well, but these models about spreading of diseases was what the authorities, I think, had in mind. Why they considered this necessary, quite independent of whether the test of this one person was really accurate in one or the other, or erred in one or the other direction. But my question is to the panel. You didn't discuss these fields much. You were into social modeling. Wouldn't it be interesting to see how these models in one area have to be followed by a model from another area, say, to get to the economic consequences of an epidemiology or something like that?
I think you're there.
Actually, well, for real situation is anyway so very, very complex. So there's no way to make a model very simple way. So the point is what kind of language and what kind of collaboration process we take. In the case of, In the case of natural language, of course, we can easily talk about that problem. But well, so it is very difficult to make a model itself to compare the different scenario or different aspect of fact. Okay, but of course, as you know, well, mathematical model is a very, very strong description model, but it is difficult to apply so complex situation like so pandemic case. Well, so it includes, for example, social learning aspect for people who faced the pandemic. So maybe in Japan, well, our university are very, very nervous, and at first I prohibited to come to here, to go abroad. I protested by using natural language.
He needed a special letter of invitation to
Yeah.
get the authority of his government to actually attend.
This is, well, another aspect of pandemic, social learning aspect. Of course, we can induce that models into the discussion. Maybe we need some description, okay? But well, in these days, social learning, maybe so, well, evolutionary economists use that kind of models. Some Markov model can be used, but it is difficult to describe in a very, very complex situation. But in the case of social simulation, if we prepare suitable toolbox, actually simulation toolbox, now we are maybe constructing that kind of toolbox for describing different type of social learning, and then so on. Then we can combine that toolbox and the discussion process. Actually, well, my smallpox epidemic model was developed only 1 month with the collaboration of different type of so specialists came together and discuss, and with some support of simulation. Okay, so then this is my answer. Bit ambiguous.
While he reaches the microphone, we should alert you that each of us is very active in our regional associations in Latin America, in Europe, in Asia, and in North America. And so if you're interested in following up with other conferences and meetings and email lists and so forth, please come see us, because we'd be very happy to provide you with that information. There are meetings coming up in the fall in Europe, in North America, and in Asia that some of you might be interested in attending, and we'd love to see you there again. Please go ahead and introduce yourself.
I'm Chad Gaffield from Canada, and thank you all for a wonderful session. And I want to try to suggest that what's at stake here is really at the heart of this whole conference. And I'm going to set it up in 2 ways. One is a narrative that seems to go through your presentations that says, in fact, we need complexity studies now because the world is simply more complex. Societies have gotten more complex and so on. And the implication seems to be a little bit is that our simple explanations might have worked for previous times, but they don't work now because society is really complex. I'd like to come at it from a different point of view as an historian to say that what's at stake here is what, in essence, our role is as researchers, in which I think there's been a cultural imperative that's pushed us down on the road of the best explanations are simple, that our mission as experts is to get the heart of the matter, to make what looks like, in fact, a very confusing, complex situation clear as crystal, and so on. And I think that epistemologically, metaphysically, what you're saying goes to the heart of our role as researchers and how we see our mission in life. And I want to talk a little bit about the notion that, and we can tie it to recent studies in neuroscience and so on, but I think there has been, maybe since the Enlightenment, the idea that all of us, and maybe it's a cultural imperative we're told, want it simple at some level, that we want to be able to make sense of the world in ways that do not confuse us and so on. that is running up against, I think, a new model of the brain, and I think you're along this lines as well, that says, in fact, the brain is happy to deal with all kinds of complexity and so on, that we don't need simplicity to get through our day, and so on. One quick example from a field that I've studied a lot, language. There was a period not that long ago when it was argued that we only could have one mother tongue.
Okay.
And this way, and there was a whole socio-cultural, institutional, underpinning for that claim, right? Mm-hmm. And now we know, I think, in terms of studies of the brain, Damasio and so on, tells us that in fact the brain happily can deal with all kinds of different things and so on. So what are we really saying here? Are we saying that we need complexity studies because we are reinterpreting what human beings need to function in the world? Are we saying that we need complexity studies because now our society is really much more complex and it's not like it used to be? Are we saying that our role as experts is not to, in fact, boil things down to their essence, and so on, to get the magic bullets and so on? What are we really saying? What's at stake here? Because I think it goes to the heart of our disciplines these days. Thank you.
I would say it's both, but I'll let my colleagues.
I'm not
answer
sure
that.
I would want to argue that complexity is useful because our societies have become more complex. I think it's always been useful, at least ever since the emergence of social complexity in some BC. But I do think that it's becoming more possible because we're beginning to understand theoretically more about complex systems. I'd also like to note something which only very implicitly came out of the previous presentations, that if one does build models, then it's not necessarily only the experts, the model builders who can use those models. There's a whole stream of participative modeling going on, in which models are built with the respondents, or the informants, with the people, and those people are able to, as it were, play with those models just as experts are able to do so. And I think that's a very interesting way forward in some areas. It's come to be known as companion modeling, which isn't a bad name.
As one could say, models are not only tools for understanding, but also for communicating. So in a way, we freeze our notion of what the world is going like into a model, and this computational model can then, something like tell a story. So what would happen if my notion of the world is the correct one? And then this can be used for communication. So the outcome of my model would not be believed by the other person, and the other person would say, obviously you must change some of your notions and let us make this model a little bit more complex. Fortunately, we do not need to restrict ourselves to very simple models nowadays. We can make models more complex, we can make our models more descriptive.
Yeah, from a philosophy or science point of view, of course, this is the business of parsimony. The two theories, the most parsimonious is to be preferred, as Occam's razor and so on. But this is all to be reevaluated now in the light of computational modeling. I'm not saying it should be discarded, but it should be viewed in a different light. The gentleman in the back had his hands up first.
My name is Eckhard Mochmann. To reduce complexity, just two functions. One is a member of the Social Science and Humanities Futures Project. The other one is the co-chair of the upcoming e-social science conference in Cologne end of June. E-social science, computational science, iScience, integrative social science, etc. We are all agents as scientists, and I am wondering about the emergence of that kind of usage of terms into the social science policy and the science policy administration area. the critical consideration here is fragmentation of social science. And you are using the tool, which is a computer, to create a new addition to the concerto of social sciences, at the same time claiming that you would subscribe to the concept of one social science. I am delighted by the thrust of all your arguments, and I agree that the complexity is the key to understanding this new direction. The complexity can be handled because the computers provide the possibility of analyzing the complexity. So I would be much in favor of stressing the complexity, and I would be rather more happy with complexity social science, but yet I would consider this to be the typical methodological approach in social science if you want to emphasize the unity of social science. We are currently under the observation of various bodies, in part also the European Commission, considering whether social sciences shall be funded as an individual track in the next framework program. The reason why they are hesitating is the fragmentation. So we should be careful with respect to this kind of fragmentation, I think, and not add to it without necessity. Thank you.
Interesting. I think others maybe would like to comment on this question of the fragmentation and versus complexity. Hiroshi or Jose Manuel, you haven't?
Okay, me. Well, actually, there's no unity in the area of social sciences, I think. But well, even inside me, there are so many fragments of knowledge. As a part-time anthropologist, field workers, well, I give a rich description in Japanese classical case studies. But well, I'm also system scientist, and also, well, I'm part-time mathematician and also part-time economist. So inside me, I use a different discipline or different language, and it is difficult to combine that one. But well, so maybe you feel that kind of fragment inside yours. But how to combine that one? Well, for domain specification or ambiguous situation, then well, natural language is very, very useful to determine the region to describe. But well, so you know the concept of rich description by Lyle, philosopher, and Clifford Geertz, famous anthropologist, used the concept of rich description. But Clifford Geertz used a very, very abstract word like involution. Well, this is described by natural language, but too abstract to apply directly to the situation. So we need some conjecture inside our brain. So that kind of ambiguity or difficulty should be compared with ambiguity or difficulty in simulation language. So, well, every language has its own benefit and defect. Then we have to learn so total balance of that kind of usage of concept in social science, I think.
Managing the time here, this gentleman.
Thank you very much. My name is Rick Leemans. I'm professor in environmental system analysis at Wageningen University in the Netherlands, and also chair the Earth System Science Partnership, which is really an interdisciplinary organization of all the global change programs bringing together natural sciences, physical sciences, social sciences from all different fields trying to solve the problems of global environmental change. I thoroughly enjoyed all the presentations and really like the progress being made with this kind of extra-oriented modeling and the kind of approaches. I want to make one comment and one question. The comment is very much to Klaus, where he put up his classification of physical systems, living systems, and human systems. And of course, for clarity, to show the difference, that's well done and well taken. But in principle, living systems, and I'm an ecologist by training, use actually physical systems and interact with them to proceed with their lives. And human or social systems are a specific case of of living system. They're not separated like the Bredesen diagram of Earth system science 20 years ago, but there are only two external forces on the Earth. One was the sun, the other were humans. Now, we are standing with both legs on the ground, and we are part of that whole system. My question is very much, if I look at these actor-oriented modelers, it's very, very similar to the type of models I was using during my PhD, the individual-based forest succession models, where you have species of trees with different traits, and they interact, they compete, and you get a spatial, diverse forest with all the dynamics and the feedbacks and the emergent properties. I think the actor-oriented models are relatively simple, and they are very strongly focused on specific questions, specific systems, where the actors have a specific lifetime. So they're discrete in their perception of time, while the physical models, the climate models, for example, have a continuous feeling of time. So my question to you is, how do you actually incorporate some of the economic models, because economists say people are not driven by their characteristics, people make choices, and the very specific feeling of time of economics, which is not discrete, is discounted. So they don't have a sense of time, they discount the future into the current. How do you bring that into these kind of models? So how do you marry economic theory with the actor-oriented models? Thank you.
Thank you. Before we answer that question, why don't you ask your question as well, and so we're sure we can start thinking about the answer. Because these are not easy questions.
Right. Neither is mine in a sense, but it may be that it's just a few.
Tell us your name and where you're from.
Yeah. Richard Lahiran from the University of Auckland, New Zealand. I need to confess I'm an economic geographer who 40 years ago was involved in linear programming, running sort of correlation analyses with an old 1620 IBM computer in order to do my masterate. But since that time, I've had a career which has really taken me through to working with what I would call post-structural political economy. Why should I preface it with those remarks? It is to identify the fact that coming to this particular conference, what I've found is it has been really illuminating to get a sense of different intellectual trajectories, sometimes of which are talking to each other, sometimes of which are bumping up against each other, and this has been a wonderful example of some of that bumping up. And it's in that spirit that I've got a number of observations that I'd just like to quickly move through. First of all, as a starting point, identify the fact that serialization and parallelization were identified. If one went into, for example, the Latourian literature, you'd find that there was an interesting emphasis on trajectories and emergence in slightly different ways to what's here. So this is not to say what you're doing is in any sense wrong, but there may be other dimensions that could be added in. The second point that I would say is that as I was listening to the presentations, some of the non-consideration up front of the background literatures that you might be working with around words like governance and such like, these are deeply problematized in other sociological, social science literatures. There are very helpful ideas in that that could be brought into the initial foundational thinking around the kind of
Could
work
I
that
press
you're doing.
you a bit to formulate your question, please, because
Well, okay,
we have
just-
only 3 minutes
okay,
left,
no,
and I want
okay.
to make sure that we address this.
Thirdly, as you're actually looking through these things, that the computations that you're undertaking are in fact new ways of knowing the world. So we're developing new metrologies as a result of that. And what becomes critical is it's not just the rules that you have for the calculations and such like, and the algorithms that you're doing, but the rules behind the rules that in fact allow you to make some decisions that need to be deeply exposed. And finally, as a geographer, I was interested to see the absence of GIS, Geographic Information Systems, which is a huge industry around the world. But the point about that is not so much that absence, but rather there are two starting points that your work could take. One, you could take the general universal sort of notion, we can do an experiment with space in its abstracted sense, or you could develop situated knowledge, which puts the accent not on so much only commonalities, but also the importance of differences. So
I see the staff coming in, checking the time. Thank you for your questions. Who would like to address the first question about the inclusion of economic dynamics into agent-based models? And Jose Manuel hasn't said anything. Perhaps we should urge him to.
Well, about just giving a comment of everything you have said is that maybe in social science we don't have much trouble thinking about the ontology of social science, but we become divided in the epistemological side and the methodological side. So the economists like time series analysis and discounting. Political sciences are turning into this statistics point of view. Sociology and anthropology, well, they like kind of case studies or small language studies. So at the end, I believe that it's not that we are divided because of the ontology of social science, but we are divided because of the methodology. So that's why I insist on Claudio Cioffi said before that this tool is helping us to maybe to unite different fields. Besides that, about the dynamics that we are concerned, because everybody's concerned about this, there are been many ways of studying that before. You have to remember that if you take a look to, there is no book about Nigel Gilbert, but he has a book about the social simulations in social science. You'll see a story of different kinds of simulations that we have had, and when I have economics students that they take for granted many things, and for them it is completely new when we talk about agent-based modeling. And when they ask these kind of questions, because they do believe, of course, what their teachers taught them, right, is that what I see is now they say that they can create these agents that they can learn. And some of them can discount, some of them they don't. Some of them can think in a way, and some others can think in a different way. So they will not be making public policy like if everybody were the same. They will be making public policy considering that everybody can have a right to think a different way, and minorities and majorities are taken into consideration. But before we finish this session, what I like most of all is that it is so good for social scientists or science in general to start having new questions. So we're making here different questions. If we hadn't talked about complexity, maybe we were making every year the same questions we make every time, using the same tools we have. But now, if every social scientist has access to this kind of conversations, they will start making different questions. Right? And we need the knowledge that everybody has. We need the experience that everybody has. And what we can provide is just a new tool so that the knowledge and the experience and the visions that you have for a better social science can be taken into consideration. So.
Thank you. I want to stress one point that Nigel Gilbert and Klaus Streusch are the co-authors of the leading textbook in this field, which is called Simulation for the Social Scientists. We actually use it in our graduate program in Computational Social Science in the PhD program. And the colleague from Japan, Hiroshi Deguchi, is the editor of a monograph series in published by Springer called Agent-Based Social Science. And so there you can find many volumes on this too. Our time is up, unfortunately, and we'll be thrown out of this room very quickly. So thank you all for coming, and if you wish to stay in touch, please let us know, and we'd be happy to exchange cards and so on. Thank you again.